Hello students, welcome back. Now let's go to section 2, transformations of graphs. We have to focus upon three types of transformations. One is shifting in x direction and y direction, and then stretching again in x direction and y direction, and finally flipping as usual in x direction and in y direction. Let's do the shifting first. The key idea here is the inverse operation. Let's begin with an example. Here we go. Let's look at the first example. We begin with the original blue graph, y equals to f of x, and then I'm going to shift this blue graph to the right by 2 units. Or equivalently, I'm going to shift this blue graph by plus 2 units in the x direction. So plus 2 units in the x direction. How do we handle that? Remember the inverse operation. We need x minus 2. You see? Plus 2 in x direction, so inverse, x minus 2. That's how you can handle the shifting. So I want plus c, we want x minus c. Now why is that? That's a bit tricky, but it follows kind of like this. For example, if x value had been 4, all right, and then I want to find out function value, the y-coordinate value of this graph, y equals to f of x minus 2. How do I do that? X is 4, so x minus 2, so go to 2. 4 minus 2 is 2. And then f of 2, so y-coordinate value following this blue curve here. And that should correspond to when x equal to 4, so move right again and right here. And you can repeat this uncountably many times for all these dots. That's the same as moving this blue 2 units to the right. Were you able to follow it? If you are a normal student, then probably you weren't able to follow that. That's okay. That's why I'm emphasizing inverse operation, so that everybody can understand. If you're moving plus c in x direction, remember inverse operation, you do x minus c. So we have 2 units in the x direction to the right. We have x minus 2 in this example. Here's the next example here. Blue graph is the original, but this time I moved 1.5 units to the left, or negative 1.5 units in the x direction. So remember the inverse operation. I'm going negative 1.5 units in the x direction, so x plus 1.5. Remember the inverse. Now, how about vertical shifting? Again, the key is the inverse operation. Let's look at this example here. Original is blue graph, and then I'm going to move it up by 1 unit, or plus 1 unit in the y direction. How do I do that? Remember the inverse operation. Replace y by y minus 1. You see, I'm going plus 1 in y direction, so we need y minus 1. Inverse operation. So y minus 1 is f of x. So flip this minus 1 to the other side, we get y is f of x plus 1. In general, like this. Y minus c is f of x, so in the end you get y equals f of x plus c. Another example here. Original is y equals f of x, this parabola, and I'm moving it down by 2 units. Or, equivalently, I'm moving negative 2 units in y direction. So, negative 2 units in the y direction. So, inverse operation, y plus 2. So, y plus 2 is equal to f of x, and flipping this 2 to the other side, we get y equals f of x minus 2. Same idea, inverse operation. So, I'm moving 1 unit up, or plus 1 unit in y direction. So, we have y minus 1 equals f of x. Here, I'm moving 2 units down, or negative 2 units in the y direction. So negative 2, so inverse y plus 2. And then after that, moving this minus c to the other side, ready for the next operation. Next, stretching. Again, the key is the inverse operation. Here's an example. Horizontal shifting by factor of 2. We have blue graph, but I stretched it horizontally and doubled it. Double the horizontal length. So this one goes to 0 to 6.2 something, but as a matter of fact, this one is 2 pi, and then stretch it by 2, so it goes to 4 pi. Now, stretching by factor of 2, so multiplying the x coordinate by 2, do the inverse operation. So we divide by 2. So in place of x, we have x divided by 2. See this? I'm going to double the x coordinate so that I'm stretching. So we go backward. Inverse operation. X divided by 2. Here's another example. Blue is the original, but this time I'm stretching by a factor of 1/3 or compressing. Okay, inverse operation. Divide by 1/3, that's the same as multiplying by 3. So here, stretching by factor of c, replace x by x over c. The inverse operation. Now how about vertical stretching? The same idea, inverse operation. This example here, blue is the original, but I'm stretching it vertically by factor of 2, doubling the y coordinate. So multiplying 2 in the y coordinate, that's what we want. So we go the inverse operation. Y divided by 2 is f of x. And then once you have y over c is f of x, flipping c to the other side, we get y equal to c times f of x. In any case, the key is inverse operation. I want stretching by factor of c, I divide by c. Here's another example. This time, blue is the original, but compression here, stretching by a factor of 1/3, so actually it's compressing. And then inverse operation, dividing by 1/3, that's multiplication by 3. So we have that. Remember the inverse operation, then you can handle shifting and stretching. One more, flipping. This one is going to be a bit easier. Flipping in x direction, so changing x coordinate, like these examples. Here we have blue graph, the original, and then flip it about the y-axis. So I'm changing horizontally, changing the x coordinate, blue becoming red, and that is replacing x by negative x. Remember, I'm moving x coordinates, so x is becoming negative x. Another thing here, blue curve is here, and then replacing x by negative x, we get the red curve, and that's again flipping by the y-axis. Curve down here is going over there, and vice versa. Now likewise, what if you flip by the y direction? Well, here we go. Y equals f of x, originally is blue, and flip it by the x-axis. So flipping vertically, thus changing the y coordinate, replace y by negative y. So y by negative y, and then flip this negative to the other side, we have y equals to negative of f of x. That's what you're looking at. So this is the original, and that's after flipping. Here's another graph, the original, and the red graph is after flipping. So putting these negatives, those are relatively easier. Stretching and shifting are a little bit harder to see, but if you focus upon inverse operation, you won't have much trouble. Okay, we want times c, we have to divide by c. If we want plus c, we have to subtract c. Ready for an example? Okay, here we go. Let f of x equals x squared. Okay, we have appropriate graph. And then find an equation whose graphs can be obtained by, and we have all these. Okay, I'll show you the graph later. let's just do graph transformation without looking at the graph. Alright, shifting horizontally by 2. So I have to go 2 units plus 2 units in the x direction. So inverse operation, y equals to x minus 2 squared. Does it make sense? So originally we have this, and then after shifting in x direction, we get that. And then stretching vertically by a factor of 1/3. Stretching by 1/3, so it's actually compression. So y over y over 1/3 equals to x minus 2 squared. And of course, I can flip this to the other side. So y equals 1/3 x minus 2 squared. So this one here is that's after number 2. Now finally number 3. Shift this vertically by -1. So vertically by -1, so -1 in y direction. So remember the inverse operation. Y plus 1 is equal to whatever that was before, 1/3 x minus 2 squared. And then flipping plus 1 to the other side, y is 1/3 x minus 2 squared minus 1. And this is going to be the final expression. Brown. Want to see the graphs? Okay, here we go. From the original, y equals x squared, and shifting to the right by 2 units, we have this red. And then stretching by a factor of 1/3, or its compression, we get this. And then take this purple and shift down by 1 unit. That's this brown. And we have this motion there, this kind of transformation. Here's a little bit simpler version. Actually, I like this one better. I like those down there better. Because we have this, and then appropriate change, we have those. We have this y plus 1 there, and then appropriate change there. So this one is a little bit easier to understand. This one, I skip those steps. So we have something elegant here, but a little bit harder to understand. This one, a little bit easier to understand. This one, I like this one better. How about the next example here? F of x equals 1 over x, and then we have to do these. Oh yeah, it's basically the same type of problem, only about longer. So I'm going to ask you to do this. Stop the playback and try. See what you get. I'll show you the answer in a moment. Well, here we go. From the original, shifting, and then this used to be y minus 1, like this, because shifting up by 1 unit, but I can flip this one to the other side, generating that. And then flipping by, and then stretching, and then stretching. In the end, that's the answer. And these are the graphs. Is there anything further? No, not really. These are just summary versions. Okay, that's the end of it. See you again in section 3.